Hello guys, we have a case to settle. So you know this what they say normally, that effectiveness comes from simplicity of application. Effectiveness comes from simplicity of application. And we have a case now. So the whole purpose of Game 3D is to challenge students. It's to challenge students to think about reasoning. And we are stimulating through application of recall. We're stimulating through application and recall using the concept, the SOFA, the TEGRAPH, the animats, and a recall 0 to 9 recall tasks. And as you can see, this is Game 3D Star Project. And this is based on one of the most stable shapes that you can find in all of the sciences. That is the triangle. The triangle is the basis of Game 3D. The most stable shape that you can find in all of science, all of human applications, is the triangle. So let's go, let's see what you can figure out from this project. So we begin our inquiry into the most stable shape in all humanity. That is the triangle. And to be more specific, we prefer the equilateral or the right angle triangle. The isosceles right angle triangle, right? With the angle here 90 degrees. Yeah. Interestingly, we have the Pythagoras theorem, one of the famous conceptions that's born from this shape. Yeah. Now this here represents the human brain. How so? The human brain exists in three parts. Well, there's a left side of the brain, there's a right side of the brain, and there's the corpus callosum. That is the part of the brain that connects the left and right side of the brain. Yes. So the whole conception is, if the triangle is the most stable shape in all of human history, why not use this as a basis to understand the world around? And that is the birth of Game 3D. So when you look at the human brain, like we said, the human brain has the left side, the right side, and then the interconnections between them, which is called the corpus callosum. So this region is what is responsible for sending information from the left side to the right side. But there is something we should note. The left side is the baller part of the brain, and the right side is the flower part of the brain. So this part of the brain, the left side, deals with letters and numbers, calculations. That is the side that most students think of as the baller part of their brain. In fact, they don't really worry about it. So this side of the brain brings out letter always. That's baller. That side brings out letter always. Let me get a good marker. Yeah, so like I mentioned, the left side of the brain is the baller part of the brain, which brings out letter always. In other words, brings out letters always. So basically brings out letters, numbers, calculations, all of those things. Yeah. And it deals with mainly counting, organizing, identifying, navigating. Yeah, so that's the coin part of the brain. Now this side is the flower part of the brain, the right side of which is the flower part of the brain. And this side, yeah, so this part, the right side of the brain, is the part that flies like owls with effective recall. Anything that goes here can be easily recollected. But anything that goes to the baller side of the brain is usually thrown out. But here's where the whole thing comes. The part that connects the two brains is the corpus callosum, which is responsible for sending information between these two parts of the brain. That is the corpus callosum. And it is this part that we seek to explore in Game 3D. Not the part where you store information by way of coins, not the part where you store information by way of flour, but we're going to the part where we make connections between these two so that we can expand and expound the emotion behind the concepts as a basis for building application. So let's expand on this and see how far the brain takes us by simply keeping this image. How far can we take this? Okay, so let me clean this corpus callosum. Get this coin out, ball out, and the flower out. So all we have is a right angle triangle. Yes. Let's get these arrows away. So this helps us to understand the Pythagoras theorem, right? So we'll call this the A side, the B side, and the C side. Right? And we know that for a square attached to the C side, it will be C times C. Square attached to the B side, B times B. Square attached to here, A times A. Very simple. The concept is in the simplicity. So A squared plus B squared is equal to C squared. Here's where things get a little interesting. Here's where, now this information is recorded in the left side of the brain. Now here's where the right side of the brain gets to engage the information here. So for one thing, I'll change this into an actual square. And this is coming from the right side of the brain. So over here, all the squares attached to A, all the squares attached to A, and all the squares attached to B. When you sum them, it will give you the same as all the unit squares attached to C. Interesting fact, right? Yes, now let's take it a little further. Now what this means is that let's play with this. So let's jump concepts. So we have atoms. Now moving into chemistry. Plus what? Bonds between them gives us compounds, right? Atoms plus bonds between them gives us compounds, right? Now we can also think about atoms. Let's jump into physics. Plus black holes give us the cosmos. Okay, it's a bit crazy, but this is the part of the brain, the right side of the brain, playing with this same concept. Now let's get a little further. So we can even get the story, the famous story of Adam, plus the beautiful, yes. And what does that result in? Yes, they definitely are the images of the creator. And by putting the two together, that's how the creator fails or reproduces objects of his kind, right? This is just by the way. Yeah, so let's play along with these squares once again. So let's jump into language. So this is the subject. And this here is the object of thought in any sentence. What part of the sentence connects these two as the verb? Do you get the connection? So we've been flipping between conceptions of math, chemistry, and then we have physics, and then religion, and then we've entered language. And it doesn't end there. Game 3D continues. So remember, we have a case on hand. Effectiveness comes from simplicity of application. Remember that. Effectiveness comes from simplicity of applications. And that is the concept of Game 3D. So in our quest to expand on this potential that the brain has, like I said, we explore this into full detail using a star project. So hopefully I'll see you in your school and we get to discuss exactly what we can figure out with Game 3D.